Back up in the woods among the evergreens, they stood a lone cabin made of earth and wood. We live a country boy named Johnny Be Good. He never ever learned to read or write so well, but he can play guitar just like a ringing a bell. Go, 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 Johnny, go, go, go. 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 Johnny Be Good. Go, 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 Johnny, go, go, go. 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 Johnny Be Good. Hello everybody and welcome to our tutorial about inductors. So today we're gonna talk about a really special subject because we're gonna finish today magnetism, and after this class we're gonna continue to waves. So what was the theme with this introduction and why we play the guitar? So I want to explain to you how microphone works, which is like a capacitor. It's based on a capacitance. This was the final subject on when we talk about electrical circuits, right? So the equivalent part in the magnetic world is actually the inductor, which we're going to talk soon. So what's happened when I use a microphone? So in microphone usually I have this kind of component. I have here a capacitor which is really sensitive to the distance between the two plates. So if I clap my hand, for example like this, I make a wave of air, okay? The wave moving and hit the capacitor plate. That's what happened, and in some frequency, for example, something that I speak, I have some frequency to the waves that I make. So this distance of the capacitor actually depending on the frequency. So the capacitor moving, there's changing in the voltage of the capacitor. There's changing capacitance. Remember, because the capacitance is actually depending on the distance, right? It's A epsilon over, the opposite way I think. D, A over D, something like that, right? The geometry and the material properties. So the voltage that I'm gonna measure on some resistance gonna change. So that's the idea how I can detect what sound I heard due to the movement of the capacitor plates. What happened when we use pickup? Hod, my friend, play electric bass. And electric bass don't have a mic inside the body of the guitar, have a pickup. Pickup is actually, as you can see here, some inductance that going around the magnet. And when you have a string, this is a string, and you pluck a string, the string is moving. See? And the string actually acts like a magnet near another magnet. So this makes a changing magnetic field. So we sense the changing in the magnetic field. We have some current and we can measure some voltage, Faraday law, what we learned in the previous class. So in inductance we actually have this configuration of formula. Remember this from capacitance? So right now this, and these two equations are really similar. Why so? Because remember that we talked about that here what we have some physics property, for example charge, and we have another physics property, voltage, and we have the capacitance. And what is the capacitance? Capacitance actually, you know, the configuration of the material properties and the geometry. And you know that from many equations, for example, F equal ma. Okay, we know force in Newton, A the acceleration, and m is the mass, the property of the material and the geometry of the material. And for example, V equal, let's say Ri. So again, what is R? R is rho multiplied by L divided by A. Again, geometry and material properties. So the same thing happened here. We have the current in the circuit, we have the changing beats, the flux of the magnetic field, and we have something in between them that connect them. and L is also connected to the geometry and the material properties. Okay, so for example, from where it's coming, we know that if we have magnetic field, it's gonna produce some current, which we know that the changing of flux, let's do Faraday law, the changing magnetic flux equal to voltage. So we want something that's gonna take us from the flux to the current immediately, which is the L, the inductor property. Okay, so right now we're gonna move to the first question, the first example, which is gonna be a really basic idea of LR circuit, and then we're gonna move to a more complicated one. Okay, see you in the next exercise.